Welcome to the Aglovad IT Solution podcast. Here you will get to hear audio describing the information that is shared in our latest blogs. And the topic that we are going to discuss in this podcast is how to scale Ruby on Rails application. So, here we begin. Today's cutting-edge and popular online apps have significantly benefited from Ruby on Rails. For new businesses, it is a great structure. But individuals commonly bring up Rails scalability issues when a startup project grows too large. A framework's ability to allow an application to grow and accommodate more user requests per minute in the future. When thinking about any technology or framework's key benefits, scalability is the first feature that springs to mind. When deciding on a technology or framework that will allow you to expand your application's functionality over time, it is imperative to consider scalability. Ruby on Rails framework adheres to the Model View Controller architectural paradigm and is built on the Ruby programming language. Scaling Ruby on Rails-based apps has become more difficult as the framework's popularity has risen. These difficulties include problems with database performance, concurrency, monitoring, and performance optimization. In this podcast, we'll examine numerous approaches to scaling your Rails app, including using load balancers, adding additional servers, and optimizing database queries. We'll also discuss typical difficulties and dangers to avoid. This manual will give you the information and resources to advance your app, whether you are a seasoned developer or just getting started. So this was a brief intro of the topic. Now let's get started. There has been discussion regarding Ruby on Rails' ability to scale for a few years now. Ruby on Rails is criticized for not being able to scale as well as other technologies. However, over time it has become evident that Ruby on Rails is the best tool for scalability. But you need the assistance of an expert, Ruby on Rails development company, to accomplish Ruby on Rails scalability. Scalability is a major aspect for Ruby on Rails. It refers to an app's capacity for managing an increasing number of users, clients, or consumers. Due to its robust application programming interface, Ruby on Rails' capacity to scale enables for the deliberate development of apps from the outset. In the long run, this ensures steady app growth. The effectiveness of Ruby on Rails and its promise to assist companies in scaling their applications draw a lot of startups. However, it also benefits consolidated companies. Moving on, let's discuss common problems with scalable Rails apps. System architecture is one of the main problems that Ruby on Rails may encounter when scaling. If your app is expanding quickly, it is not a good idea to use this framework to build it. In addition to problems with performance, you could encounter other problems. However, this doesn't mean that Ruby on Rails scalability is impossible and always fatal. Some of the others problems include poor memory management, inadequate database engines and caching, poor indexing, coding splitting, application server constraints, and many others. Working with Ruby on Rails has become simpler because a large number of answers to problems have already been documented by the framework. The analysis and classification of system bottlenecks can be done using thousands of open source tools available. Now the question arises, is Ruby on Rails scalable? Yes, Ruby on Rails is scalable. A framework's scalability refers to the potential for an application created with it to expand and handle more user requests per minute in the future. However, it's crucial to remember that the architecture of the complete server system should be scaled, not just a framework. To get the better idea about the concept, let's look at a Rails project's overall server architecture at this early stage. What we usually have is a single server on which we install the following software: A. Nginx server. B. Rack application server Puma, Passenger, or Unicorn. C. A single instance of your Ruby on Rails application. And D. A single instance of your database is usually a relational database like PostgreSQL. The above-mentioned Ruby on Rails architecture is enough to handle 1,000 or 10,000 queries per hour. However, you receive tens and hundreds of times more requests after your software becomes popular. Under strain, this Ruby on Rails architecture will fail, rendering your program inoperable for users. This is where the Ruby on Rails scalability is helpful. Next, let's discuss how to scale a Ruby on Rails app. Starting with procedures that don't require complex scalability will help you scale a Ruby on Rails application. Implementing code simplification is an intelligent approach to begin with. Although it demands time and resources, it has a good impact on optimization and the abolition of future issues that might be connected to it. Other options exist, but scaling in its horizontal and vertical forms is the most relevant. The application can be scaled vertically and horizontally, as with any technology. In their contexts, each strategy has advantages. The vertical scaling will be the first tactic, and we'll take it from there. Vertical scaling can boost the number of RPMs by giving the program access to more server resources. The fundamental assumptions are the same for all systems. You keep adding more RAM, processes, and other components until it is technically and financially possible. Vertical scaling is a temporary, patch, solution, which makes sense. Since cost control will be simple, scaling Rails projects vertically makes sense to handle linear or predictable growth. Additionally, upgrading database servers is a suitable candidate for vertical scaling. After all, putting slow databases on better hardware can significantly speed them up. Vertical scaling is constrained by hardware. However, scaling Rails projects vertically can be difficult even when employing cloud resources. For instance, if you intend to use Kubernetes vertical pod autoscaling, it still comes with several restrictions. Taking this podcast ahead, let's discuss horizontal scaling. A technique for scaling Rails programs that is more future-proof is horizontal scaling, which involves dispersing your workloads across several servers. This means that you can divide your application into the server, load balancer, which is Nginx in this case, app instance and database instance are divided in such a way that it allocates it in smaller and equal loads among the machine. The fundamental goal is to distribute loads evenly among several machines to achieve optimal performance. For this you must pick the best web server and load balancing solution to reroute Rails processes between server instances successfully. After that, adjust the instance size to the freshly decoupled workloads. Let's take each one of them in detail. We can scale a Rails application horizontally, similarly to how we scale with many other frameworks. Horizontal scaling of a client or server architecture means converting the single server architecture of your app to a three-tier architecture where the server and load balancer, Nginx, app instances, and database instances are located on different servers. In such a way, we allocate equal and smaller loads among machines. A. Nginx. It is a popular server program for Rails apps, is installed and utilized as a reverse proxy and load balancer on a single machine. Because Nginx requires little CPU power to operate regularly under heavy loads, you need a medium-powered server to run it. Filtering and distributing the load among numerous servers is Nginx's main objective. The server is configured to forward the initial request to the first machine, while the second machine will get the other request, and so on. And as the server receives the NAXT request from the browser, it will automatically be forwarded to the first computer if other machines are busy with Rails application instances. B. App instance. You require an additional server to perform the instances independently of Nginx. Although the app appears to be the same from the user's perspective, Nginx causes them to view a new app instance. With a unique interface called RAC, Nginx can communicate with other programs. The most well-known servers for Rails-based apps are Puma, Fusion Passenger, and Unicorn. These application servers deal with user queries. Despite the monolithic nature of Rails apps, it is still possible to remove a functional block and utilize it as a separate service, which would ease the strain. C. Data instance. Scaling a Rails application requires, among other things, scaling a database. We can put a database on the same server as the application to save money. However, this cost-saving measure has several limitations. Data for the entire application is scattered across numerous workstations when each application saves and gets data from its database instance. For website visitors, this is incredibly annoying. Because their data is stored on a different machine, users whose Nginx redirects to a separate app version from where their data is stored cannot sign in at all. To establish a fault-tolerant design, it is also necessary to keep databases distinct from other servers. Our database will crash if it is unable to handle too many requests. However, the data tier's other database instances can take this demand. Thus the Rails app will continue to function. It is crucial to move your database to its server as soon as you scale your Rails applications because of this. A single server that houses a database used by every app instance can act as the database layer. Another two options for reducing the load on a database are Redis and Memcache. These are specially designed database that performs read, write operations extremely fast. These were two approaches to scale your Ruby on Rails application. Now that you know how to scale the Ruby on Rails application, let's move on to the Rails best practices. Every framework has some best practice that helps them achieve the best possible results. Ruby is similar. Following are some of the Ruby on Rails best practices. 1. Simplify the code. Refactoring constantly is time-consuming and might lead to significant performance optimization problems in the long run. Alternatively, you may use a simpler, straightforward language to combine with ROR to write tasks that need more processing capacity. 2. Save app state. The following code optimization for horizontal scaling may become more challenging if the saved state stays on the server. To prevent optimization problems, the client should keep the current state. 3. Optimize client-side caching. Utilize a client-side cache and AJAX libraries like jQuery to send data to the browser as needed. Learn how to employ expiration and ETAGS and leverage gateway or reverse proxy caches to cache HTTP replies on your website. Make the most of the process, web page, and segment caching that Rails includes. Instead of retrieving results from your database, use Memcache to store them. 4. Minimize the external dependencies. Keep an eye out for reliance on outside services like RSS feeds or ad-serving networks. Make sure you have a backup plan in place if a service goes down or cannot accommodate your increasing demand. And 5. Split up the relational data. Your MySQL database must be partitioned at high scaling levels. Your datasets will be divided into parts using a key in the sharding process. Sharding based on user IDs is one option for many consumer-focused Rails sites, although alternative sharding techniques employ data age or frequency of accessing data instead. To sum up, scaling a Ruby on Rails application can be difficult and complex, but with the correct strategy and tools, it is possible to get good performance and maintainability. One such tactic is utilizing a load balancer to split traffic between several servers and prepare the database for high concurrent access. The strain on the application server can also be lessened through caching and background job processing. Overall, it's critical to regularly check the application's performance and change to ensure it can accommodate the rising demand and traffic. With this, we are concluding this podcast. Thanks for listening. For more such informative content, keep following our podcast.